Good evening, one and all. The subject name is compiler design. Now we are going to discuss about some of the problem solving techniques in the topic that is syntax directed translation and intermediate code generation. Now in this we have generated various forms of parse trees and syntax trees in the previous examples. Now in this we are going to verify the parse tree, that is 3-address code. How to 3-address code is generated with the and draw the directed acyclic graph with the expression a plus this one. This is the expression. So, but this expression contains operators, how many operators and operates. How many operators and how many operands. So here the operands are a, comma, b, comma, c, comma, d, and operators are plus, minus, star, like this. So now in this the more than 3 operators, and operands are also 4 operands. So that's why it is not a this statement, this expression is not a 3-address code statement. So where 3-address code represents at least 3 operands, at most 3 operands, and at least 1 operator is required. So this is the constraint for the 3-address code notation. So in order to meet that requirement, so we can have the, that is what is a b minus c. That is, first initially we are going to write a temporary notation t1 where equal to b minus c. So here only one operator which is to be considered, that is minus operator, subtraction, and we can perform with this one, that is a star t1, because t1 is already considered this one. So this is to be assigned with some t2. Now t2 plus a. So a plus t2. So this is to be considered as t2. So a plus t2 is 1. Now that is t3. This is comes under t3. Now already b minus c, which we can consider, which we performed with t1. Now t1 with star d, we can make t4. Suppose this one is t4 and we left out with 1 plus operation, you make a t5. So that is the what these 5 statement 3-address code notations that are available. So for each of the class, here the star operation, here plus operation, star operation, here plus operation. Now if you perform the 3-address code, that is directed acyclic graph representations, where b minus c, that is b minus c, that is to be considered as minus as internal node, and b and c are the operands. So to the b minus c, what is to the left of this one? So that's why here a star. So here star is the internal node. That's why you consider star. To the left, which are having a. So we have performed a, and to the right we are having b minus c. And for plus, which is having to the left plus a, and to the right. So here plus a plus. So here a plus, once again a star b minus c. So once again it is a, instead of writing a separately, we have given a branch indicating that one. So a plus a star b minus c. This is the, and for this plus operation to the right of this one, b minus c star d. So star is the operator. To the star left of this one is b minus c, which already we calculated, left children, and to the right of this one we are having a d operator. So the right of this one we are having d. So in this way we are going to represent a DAG representation where operands and operators are to be written as internal nodes, that is non-leaf nodes. Non-leaf nodes where operands are written as leaf nodes. And in this way we are going to represent a 3-address. So this is not a 3-address code. We have splitted that one into a 3-address code, and then we have formed a graph representation. Now one of the most important one is, what is the construct triples, indirect and quadruples for the expression x equal to y star minus z plus y star minus z. So previously also we have seen equal to is an operator, and to the left we are having y, and to the right we are having star with left y and unary minus z, unary minus z. So this is the unary minus, and for equal to plus is the operator. Right we are having y star minus z, and right, left and to the right also unary minus z. To the plus here y star minus z, if you consider the plus as the root and leaf node, and to the plus and to the right also we are having y star y minus z. Like this we can represent the diag representation. Now actually here we are going to concentrate mainly on not representation. In the previous we have seen the representation for main purposes here quadruples, triple and indirect triples. Now here quadruples, first if you consider the quadruple notation, where quadruple notation contains 4 fields. One is opcode, argument 1, argument 2 and the result. Here this opcode, that is operator, argument 1 and result. But these are to be in a 3 address code notation. Here 3 address code notation represent x equal to y star minus z plus y star minus z. X equal to y star minus z plus y star minus z. Now here what is the opcode that is to be used for the purpose? Here we are going to represent this one into a 3 address statements. 3 address statements are to be represented as first one this unary minus z, that is to be considered as one statement T1, and after that y star T1 that is to be considered as T2, and as z unary minus z, that is T3, and T4 equal to y star T3. Now T2 plus T4 T5. Now x equal to T5. So this is 1, 2, 3, 4, 5, 6. So that is what 0 to 6. That is what 0 to. So here T1 equal to minus z. So this is the T1 equal to minus z. Now T1 equal to minus z. What is the operand argument 1 here? Result is stored in T1. So that's why here that is the result, it is T1. Whereas operator unary minus operator, so unary minus, and the argument 1 is argument 1. Where is argument 2? There is no argument 2. So that's why it is empty. It is given as empty. Whereas in the second one, T2 equal to y star T1. T2 equal to y star T1. So here, what is the result? The result is T2 and operands are y. So that's why first argument is y, second argument is T1. And the operator which is performed here, star operation. So this is the star operation which is performed. And for the third one, T3 equal to minus z. So we already performed T1. T1 is which is same as T3 also. So T3 is stored the result, and minus z, unary minus, and z is the argument 1. And next one is T4. T4 equal to y star T3. So here T3, T4, y. T3, y and T3 are the argument. Y is argument 1, T3 is argument 2, and the result is stored in T4. So that's why here this is T4. And what is the operation which you are performing? Star operation. So star is. And for fourth one, T2 plus T4. That is T5. T5 equal to T2 plus T4. Now what is result is stored in T5. But argument 1 is T2, argument 2 is T4, operation which you are performing plus operation, and the result is stored in T5. So T5 is the result. And finally x equal to T5. And x equal to T5, here T5 is the only argument 1, there is no operator, and assignment, that is why you can take it as assignment operator, and the result is stored in x. So that is the x equal to. So this is the format which is represented by the quadruple notation, where the given expression, where this given, which does not contain a 3 address code notation, so we have to represent that in the 3 address code. Whereas in the triples, so this is the triple representation. In the triple representations, which is having 3 fields. One is operator, argument 1, argument 2. But here, what is the difference between quadruple and triple? Here triples, we are not using T1, T2, T3. Here it is excluded. T1, T2 are not to be used. Instead that we are going to give a reference to the instruction. So that is one advantage. Another one is these are also called as 2 address codes. Whereas quadruple, that is 3 address code, triple, it is a 2 address code. And compared to the quadruple representation, it takes less space. Why? Because the result and this one it doesn't take, so that's why it consumes very less space when compared to the quadruple. So here we have seen here, for example, if you see T1 equal to minus Z, for this expression T1 equal to minus Z, so what is result? Result we are not going. Only the operator and argument 1, argument 2 take. So that's why previous table you have to keep operator argument 1 as it is. Only the difference argument 2 we are not taking. So instead of argument 2, what we are taking, what is the result it is, what is the T1? T1 is the previous instruction. So that is the reference of the instruction 0. Previous result is 0. So this result instruction is to be written. And 2, where is 2? That 2 result, it is to be passed here. Why? Because y star T1. So where the T1? This is the 2 which is to be. And for 1 it is to be taken here, reference. And 3, the 3 is, what is this 3? Y star T3, which is T4. T4 is y star T3. Now once again this T4 is used to be in plus operation. So thus T3 is to be considered as this address reference instruction. T4 is the address of the instruction, and then plus is the operation, and result is stored in this one. So this is the fourth. So this finally this fourth statement, address reference instruction 4, that is to be stored as a part of this last instruction, and then fifth is the last one, so it is not used anywhere, so it is kept as T. So x equal to T5. Now here what is the difference between this previous table and this table representation is, operator is to be used in the same way as it is with the list of instructions specified, and argument 1 is also which is used to be same. But instead of argument 2, what it contains T1 and T2. So here T1 and T2 are not going to be used. So instead of T1, T3, T4, we are going to write a reference of the instruction 0, 1 by making this list reference 0, 2, 1, 2, 3, 4, and then we are going to compute this as triple representation. Quadruple, triple representation. And third one is indirect triple representation. Third one is indirect triple. So here indirect triple representation, we are going to use a pointer to triple. Instead of triple, we are going to write a pointer to triple. And here we are going to optimization by moving the code around is easy. We can perform by implementing this procedure, we can perform this code optimization. And compared to this quadruple representation, it also takes very less space. It takes very less space. And both indirect triples and quadruples are almost equally efficient. Both indirect triples and quadruples are equally efficient. But that means Quadruple representation, we are having operand, argument 1, argument 2, result. That is the same which we have get here, but operand, argument 1, argument 2. Previously, what operator is used in the same way, argument also we can use. But here, argument 2, we are going to write a reference of the instruction which is specified in the previous. So, we are going to write down this 0, 1, 2, 3 with corresponding statement numbers 14, 15, 16, 17, 18, 19. So, that 14 statement which gives the reference to the instruction where that is unary minus z. And 14 statement, what is here 14, what is the result which we got? That is minus z, y star minus z. Again this one which get minus z. Again we get y star minus z. So here we are performing 15 plus 17. 15 plus 17 means y star minus z plus y star minus z. And finally that is x is assigned. So x equal to y star minus z plus y star minus z. So in this way we are going to describe the reference of the instruction made to the corresponding each statement. So that statement number is to be written with the argument 2, and this argument 2 is to be expanded with the corresponding notation as specified in the operator. So here the operator is to be considered, argument 1 is also considered, but instead of argument 1, where the instruction numbers are specified in the triple representation, that is reference instruction. That reference instruction is replaced with the corresponding. So previously we have a reference of the instruction made for the corresponding statements. So 14 corresponding instruction, 1 reference instruction with statement 16, 2 reference instruction with statement 16, 3, 17, 4, 18, 5, 19. So this same can be represented as a statement number wise. For each statement wise, we are going to write that reference with the corresponding. So instead of 14 where 0 appears, so we are going to write 14, 16, 15 like this. And then we are going to get the final x equal to y star minus z plus y star minus z. So this is the final representation which is used for the notation of this indirect triple representation. So another example which gives the syntax directed translation for the notation, that is 3 plus 4 star 5 plus 6. So here we know that semantic rules are supplied for each of the grammar in the given, and we are going to list out the semantic rules. Previous also we have discussed about the semantic rules. What is the attribute associations for the corresponding each values, attribute association of values for each symbol, each terminals which are described in the production, that is to be described here as a list, and then that is called as semantic rules. Now we can generate easily with the help of this production rules, that is 3 plus 4 star 5 plus 6, where the lexical answer, that is L start with corresponding starting root node E, and E derives T, and T derives, you can take this one, these two expressions or derivations which you have to consider, and for T we can take T star F, why? Because the star operation is required, so T star F, and for T again F, and with expression F is expression is E plus T, where E is T, now and plus T is F. Now F is a digit, so F is a digit means we can consider it is a 4, and T derives F is a digit, so here it is 3. So this is to be replaced with here 3 plus 4, and star operation 5 F is, we can consider here F E, 3 plus 4. Now T star F is the expression E, so expression E contains E plus T once again, so same way here E plus T. This E plus T which is derives in the left side sequence what we get. Similarly E derives T derives F, that is value 5. here treated as f and the value is 6. Now this 5 plus 6 used to be carried out to the root node, that is 11, and this is with this one. So this is 11. 3 plus 4, that is 7, used to be carried out this result 7, and 11 and this 7. So this 7 star 11. So that is 77 passed to this one, and finally this one. So the same that can be achieved with this value, construction of the parse. This is attribute association values. Previously also we have seen. So that is how we are going to draw the annotated parse tree for the expression of the values which is specified. In the previous example also we discussed where these things we have to write with this one, and where the attribute value e dot val plus t dot val, where that is expression is evaluated with the corresponding e dot val. So 3 plus 4, that is 7, which comes this value 7. Once again this like this, the digit value passed here 3, again 3, again 3. Now here 4 passed to 4. Now 3, here 4. Now the value 3 plus 4, that is generated 7, it is passed to 7, this 7. This side here, this is 5, this is 5, and brief note, this is 6, 6. Now 5 plus 6, that is 11, which is passed to this one. Again 7 star 11, which is equal to 77, passed to this one. So like this we are going to generate annotated parse tree, and we can expect the result of this one. Okay. All the contents which are available in this book can be available by compilers principal techniques alpha development. Thank you. We'll come across one more new problem solving technique in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.